Today we will be solving round 963C light switches, where you are given an apartment of n rooms which each light is initially turned off. Now, to control the lights, you install chips in the room such that the chip at A of I starts at A of I time. Now it changes the light status every k minutes, which means the light is on for k minutes, then turned off for k minutes, then again on for k minutes, and so on. You need to find the earliest moment where all rooms in the apartment have their lights turned on. Now, since the value of A of I is 10 raised to 9, brute forcing this will give time limit exceeded. And with any use of priority queue or map, it will be very difficult to fit this under time limits. Hence, we are going to attempt a greedy solution. Now, what will our greedy solution be hit on? Now, if you see for the first test case, that is where we get an idea. In the first test case, all of my switches are in a range, like my max is 5, min is 2. Hence my range is 3. My range is 3, k is 4. Hence my range is smaller than my k. And because of that, all of my lights are on at the maximum of this range. So if we try to bring all of the elements together in a smaller range, and if that smaller range is less than k, then that means at the maximum value of the range, all of the switches will be on. Now, why the answer for this is -1? Let's try to bring this in one range. Okay, it is 2, 3, 4, 5 with k is equals to 3. Now, we have to bring all of these in one range. If you look carefully, let's say you are starting on 2. If you plus 3, you get 5, where your switch is off. Again plus 3, you get 8, switch is on. Again plus 3, you get off. So if you look carefully, if you add 2k or 4k or 6k, at that moment, whatever you are getting, the switch is on at that moment. Whereas if you are adding k, 3k, 5k, you are getting off. Hence, we will try to add multiples of 2k. Okay. So if now see, I I have sorted these elements, and I will try to bring my max closer possible to my min, close possible to my max. Okay. Currently the difference is 3, which is equal to k, but I want a difference that is less than k. So I'll perform the operation. This becomes 8. Why I added 2k? The range is still equal to 3. Now the more I perform the operation, the range will increase. Hence there is no possible solution for this case. Now let's go for the next test case over here. 3, 4, 8, 9. 3, 4, 8, 9. K is equals to 3. Same logic, we will add even multiples of k. Okay. So I will add 6 to 3, make it 9. I will add 6 to 4, make it 10. 8 and 9 is already close enough, don't need to add it. So I getting 9, 10, 8, 9. 9, 10, 8, 9. Difference between max and min is 2, which is less than k. So the answer would be the maximum of this range, and that is your answer, 10. Let's try this on this test case as well for a better clarity. We have 14, 34, 6, 14, 34, 6, 25, 46, 7, 17. So first, min is 7, max is 47. My k is 5, so I can add multiples of 10. 7 becomes 47, 6 becomes 46, 17 becomes 47, 25 becomes 45, 34 becomes 44, 14 becomes 44. Hence my max is 47, min is 44. So my range is 3, which is less than k. Hence my answer is max 47. Now the question would be, if I am adding multiples of 2k on and on and on, won't I get TLE? So we can speed that process using binary search. How will we speed that process using binary search? Let's say we are adding a multiple x. So we have to add x into k. Now my x could be in between 1 to 1e9. Okay. Now if we are at a of I and this is our max at a of n minus 1, we want this value to be greater than this at least. So we will take mid of start and end, and if keeping mid over here we can get a value greater or equal to this, then that is one possible answer, and then I decrease my end to search for a lower x. And if after multiplying x into k it is less than this value, so I will increase my start pointer and search for a higher k, search for a higher x. Okay. Now I will show you how to implement this. It is in Java, but I will submit C++ solution also after system testing ends. Okay. So first I sorted my array. And I made two arrays, B and C. Why B and C? Why two arrays and not one? Because I wanted to test two conditions. Let's say our max is 15 and we are at 4. K is 3. So I can make this 10, I can make this 16. So I will store both 10 and 16. Okay, I will store both 10 and 16 and see which of them gives a better answer. Why? Because let's say we have a value 14 and 14 becomes 20. So in this case the smaller value is better. Okay, so we perform basic binary search. Mid turns into x and into 2 for even multiples. If my value is greater, that is one possible answer, decrease my end, else increase my start. Now I make two values, value 1 and value 2. Value 2 is the regular one, value 1 is one operation less. Why? This reason, because 14 is a better choice and not 20. So I chose both values, value 1 and value 2. Difference is only answer minus 1 and answer. Okay, B of I and C of I. B of I for one case was coming negative, hence I made that like this, so at least the value is A of I. Now I am making a final array which stores the final range. Now first I will see for the smaller value. I want the minimum possible answer. So I will check for the smaller value. If my max minus current value is less than k, which means I can choose this as my answer. Else I will have to choose my bigger answer. Now these are just functions in my template uh, to return the maximum index and minimum index of the max and min values. So d of max index gives me max value, d of min index gives me min value. If this range is more than or equal to k, I print -1, else max is my answer. If you have any doubts, let me know in the comments. I will add C++ code after system testing in the comments as well. Okay. So thank you guys for watching. Make sure to like, share and subscribe to never miss another tutorial.